Hello everyone. In this video, we will learn the factor theorem. Now in our earlier video, we have looked at the remainder theorem and we know that we have px and we have another polynomial x minus a. So if we divide px by x minus a, then we get a quotient qx and a remainder rx. Since the degree of polynomial x minus a is 1, degree of rx is 0. So this becomes x minus a into qx plus r. So polynomial px, when divided by a linear polynomial x minus a, gives a remainder r, and the value of this remainder is same as p of a. That was the remainder theorem we learned in our earlier video. That value of the remainder, in case px is divided by linear polynomial x minus a, it is same as p of a. Now let's state the factor theorem. Factor's theorem states that if px is a polynomial of degree greater than 1 and a is any real number, then x minus a is a factor of px if pa is equal to 0. It also states that if pa is equal to 0, then definitely x minus a is a factor of px. So let's put this here. So we know we can write division in this format. Px is our dividend and x minus a is our divisor. Divisor into quotient. Quotient is going to be another polynomial in x, and there will be a remainder which is another polynomial in x. Now since the degree of divisor is 1, degree of divisor is 1, that means degree of remainder has to be less than 1. Less than 1 means 0, and hence we can write this as px is equal to x minus a multiplied by qx plus r. R is a constant because degree is 0. Now what we are saying, if x minus a is a factor, x minus a is a factor of px if pa is equal to 0. If pa is equal to 0. But as per remainder theorem, we know pa is r. So we can rewrite this as px is equal to x minus a into qx plus p of a. Because we know as per remainder theorem, p of a is equal to r. That is what remainder theorem states, and we have proved that. And now let's look at first here. If pa is 0, if this is 0, then what px will look like? Px will look like x minus a into qx because pa is 0. And that shows that x minus a is a factor. Correct? It is a factor because it is multiplication of x minus a and qx. So these two are factors of px. So it is proved. The first thing is proved. Now let's look at the second one. Here, if x minus a is factor, what we are saying is if x minus a is a factor. So for second, we are saying if x minus a is factor of px. If x minus a is a factor of px, then px must be x minus a multiplied by some polynomial in x. If it is a factor. Now comparing these two, this is true only if PA is 0. And therefore PA has to be 0. And that is what is proved, because if x minus a is factor, PA has to be 0. If PA is 0, x minus a is a factor. And that is what the factor theorem states. Now how it is useful? It tells us if we have polynomials, we will be able to find the factors just by looking at P of a. If P of a is 0, we know that x minus a will be a factor. Or if we know x minus a is a factor, we know that P of a is 0, and we can equate P of a to 0 and find any other unknowns. We'll solve a few sums and we'll understand the usage of this factor theorem.
I am sure you have liked the video. Hit the like button and leave your views in the comment section below. Do watch our other videos on this topic. Subscribe our channel and click the bell icon to get notifications whenever we upload new videos. You may also download the YouTube app at the link provided in the video description. Till we meet again, goodbye.